Hello everyone and welcome to this unboxing. Alright, so the first one is something interesting. This is Moritz Klein's voltage controlled filter. And I just made a very quick design just to check if I can get it to work with the SMD components only. So this is a bit of an experiment. I'm not actually sure if this will work or not. So let's see when we build this. The whole idea is to use surface-mounted components as much as possible. So I'm not using matched diodes or film capacitors or anything. Everything is bog standard SMD. So I will build one of these and test it. Alright, the next package is a little bit interesting as well. This is actually the first time I use the SMT service at the JLC PCB. So let's see if we can unwrap this and okay. All right. Okay, the packaging was a little bit interesting. But let's using Kapton tape to hold this together. Okay, yeah. Okay, so this is a 2 HP buffered multiple, and in order to fit everything on 2 HP, I actually had to use single gate op amps. So these are SO23, SO23-5 types with that are basically placed directly under the jack itself, so it doesn't consume any. that is what basically the only place that I could fit them. So it has two sections that are you have one input and two outputs like this, and here and a second one, and the second half is normaled to this one. So if nothing is plugged in here, then it will be connected to the first one. So I can have two 1-to-2 mults or 1-to-4. And yep, I really tried to fit everything into one PCB here. That's the whole point with this experiment. And it will be very interesting to see if I can put this together and what it will look like. I have not done the front panel yet, but I will do that quite soon, I think. I just want to make sure that this thing works before I spend any time on doing the panel. Okay, so in the next package I have so this is a front panel for my VCA. Okay, so this is the front for the VCA from Music from Outer Space, and the design is made by Ray Wilson. And I think that they look quite nice. So I will put this together. I already have 2 PCBs that are assembled, and I have 3D printed panels on those. So I will put these on instead. Okay, so the next package contains 2 PCBs. First we have a front panel for my buffered malt, and I decided to make these with aluminium. Yeah, let's hope that they are not too much scratched, but they actually seem to look okay, I think. So I will feature these in an episode about my buffered malt project. Next one we have a bit larger PCB. This is a filter board. I have some problems with interference in my big Eurorack case, and I have done some troubleshooting. First I thought it was one of the modules that were sort of very receptacle to or sensitive to disturbancer or EMC. But it actually turned out that the power supply is sort of generating a tone that is quite annoying. So you can hear it if you crank up the volume a bit. And so I made this is a quite simple design. It's only a LC filter, or actually 2 cascaded LC filters that are used for filtering the 12 plus 12 and minus 12 volt rails. So I will feature this board and the outcome of this in a separate video about my issues with the Eurocase rack. So stay tuned for that. Okay, so the final module for today is this one. So this is a DIY kit. It's something called Knits, which is a 6 HP version of Mutable Instruments Platts. And yeah, it's quite small, as you can see. And it contains, I can show you here, it contains pre-soldered SMT parts, and you basically only solder the through-hole components. So it's 2 PCBs stacked together with the header connectors, and then there is the front panel, aluminium front panel. And there's also some more stuff, stickers, and I bought this from Pusherman, and yeah, the manufacturer is Antumbra. And there are various, yeah, a lot of stuff in this. I will actually make a separate build video of this, so I will not go through everything. So hope you found this interesting. As you can see, there is a lot of projects going on, and I'm actually not that far from having a complete signal chain for subtractive synthesis synthesizer. So so yeah, I'm really looking forward to start making some more noise in the future here. All right, thank you for watching, and I'll see you in the next video. Goodbye.